Okay, so I'll be talking about Apache Kafka and pushing messages with it. So first about me, I'm Hristo Mohamed. I work in CERN in the LHCb online experiment, and I'm a system procrastinator there. And I have very shitty drawing skills, so later when you try to see my illustrations, please don't laugh at them. I'm mostly doing monitoring and configuration management there, and also try to make sure Linux behaves with our very shitty legacy code. And also like Half-Life, as you can see there. First, to talk about where I work and what is LHCb. I skipped a slide. So basically it looks like this. It's a lot of different detectors, which are basically a lot of different cameras shooting things. And we have like the collider, particles are hitting each other, things are getting shot, people are analyzing data, and so on. I am not really the physicist person here to explain things, so I can like read what is written there. For the 3 years I've been there, I didn't really learn what is a B and anti-B quark, or what is B meson. But yes, I can tell you this, and not more. But I'm going to talk about Kafka, and what is Kafka. So basically after this we can like end the presentation. I didn't find a nice picture about bucket getting filled with a lot of water that was like free to use with a free license. So I just took this one, which is not very exemplary, but it will have to do. On my next slide, I have what is a Kafka cluster. It's multiple of buckets getting filled with a lot of water. And you know, it's these very old buckets that you don't really care about so much, but they're still getting filled pretty well. So first, let's see, how did I meet Kafka? I'll go through my path of meeting this technology and using it in my work. And so first, I was tasked to implement ELK. So who here is doing some kind of operations? Only a few people? OK. So I guess all of these people know what is an ELK. So ELK, it's like Elasticsearch cluster, and you have a log stash, processing logs, and you have some kind of log shipper, and the K stands for Kibana, which is like visualizing things, but this is the least important part. So first I looked at this, and I was, OK, this looks pretty cool, but I found a lot of problems. First, I wanted to use virtual machines or very shitty old machines for the log stash part. And all this is very prone to failure, and I was thinking, what happens if they die? I mean, I have to do some kind of high availability of load balancing, and then things became really complex, and I'm not that smart, so I was like a bit baffled what to do. My log shippers would somehow not give my data, they would have to store it, or do 1 million other things they're not supposed to do. So this didn't seem kind of quite correct to me. So then I continued to Google what to do. Of course, I was not the person who invented the thought of this concept at all. And then I found Kafka. Of course, Kafka is nothing more but a message queue. So basically, you're just pouring inside messages. It's like a fire hose for your millions of events. So this is not only for an ELK cluster. This you can implement in many other ways. Maybe you want to use collectd with an InfluxDB engine or a graphite engine or any kind of collection mechanism that generates like hundreds of thousands of metrics per second, and you want to push them somewhere. And I found Kafka to be quite a very good choice for this. Of course, there were other things that I found through my Google queries, like NUTS or RabbitMQ, or a lot of other technologies doing that. But at the end, I stopped at Kafka. Why? So first, I think this photo can actually like base and it can summarize the difference between Kafka and RabbitMQ. Kafka is on the left, RabbitMQ, no, let's see. Kafka is on the right, RabbitMQ is on the left. So Kafka is basically a shitty bucket that is maybe leaking, maybe it doesn't collect all the water correctly, but you just want to fill it more and more with water. And RabbitMQ is this very advanced and nice metal bucket that you have, that you can pour, but you have to pour slowly, because you can somehow break it if you pour it too fast. Or you have like all of these nice advanced mechanisms. While in our stupid bucket, we cannot really lift it properly because we don't have handles. This one has handles, for example, and it's really good on our hands. Some real differences between those two guys. So for RabbitMQ is a smart broker. By this, we have a lot of the logic of RabbitMQ is inside the broker itself. And we have a dumb consumer in most cases, or we're supposed to have a dumb consumer. Here we care more about managing our broker, not our consumer. So RabbitMQ is very broker-centric, which it's kind of not very nice if you want to do a lot of horizontal scaling. Kafka is quite the opposite. In Kafka, everything that is not just taking messages and giving them from producers and giving them to consumers, it's not in itself. I mean, most of the control logic is not there. It's very consumer-centric. By this, we mean that the consumer has to take care of everything. We have very different use cases. I mean, the throughput of Kafka, I will demonstrate later on machines which are probably, some people here were not even using computers by the time these machines were made. It's amazing. So majority of people say that on a Kafka cluster you can do 100,000 messages per second easily without any tunings, while on RabbitMQ that goes to around 20,000 messages. Of course, there's many people who are using RabbitMQ in a huge installations like Google. So Google managed to do a 30-node cluster of RabbitMQ doing 2 million messages per second, which is very nice. But these machines were really beefy. They did a lot of tuning on the queues of RabbitMQ. They did a lot of tuning of RabbitMQ itself. And this is not what we really want to do with Kafka. For me, when I started with Kafka, I just wanted this to work fast, and take all the millions of log messages that, I don't know, I forgot to not tell cron to log me this or whatever. I wanted them to go there. Also, in RabbitMQ, it's a lot more mature. You have a lot more implementations. You have a lot more nice things about it. And AMQP provides a lot more complexity than the Kafka. The Kafka protocol is dumb. You have queues with partitions in there, which we'll talk about later, and you're just filling them. And you know, this comparison can make 1 or 2 talks by itself only. Then there was the other competitor that I saw on the market, which was Nuts. So Nuts is written in Ruby, and it's really, really fast. People invented it for a Ruby-made message queue. But when I was doing this, there was no replication supported in Nuts, and there is still no replication support there. While this is a big problem that even when they implement it, this will take a lot of time of testing and putting it into production environment, while LinkedIn were using Kafka already for a long time in production. And clustering in Nuts, I wrapped in Q1 of 2017, and you know, it's still not entirely super stable. And also Nuts supported smart or dumb broker, depending on you, but the lack of clustering really, at the time when I was doing this, and even the lack of replication now, really threw me away from this project. So now let's talk Kafka. So in Kafka, when you open the documentation, you're immediately bombarded with this new lingo that you see. So you have something called brokers, topics, partitions, consumers, producers, whatever. So these are all very easy, but you know, if you have to start reading documentation. So each node in the cluster, it's called a broker. And all the messages that you're pushing to the broker are split in topics, and each logical representation of a topic is made of partitions. And you have, of course, you have producers, which are things that produce messages, and you have consumers, which are things that consume messages. As we had here, we only care about that the consumer is smart enough to track what he's doing, the producer, not so much. How a topic looks like. I stole this photo, you cannot see it, but I stole this from the documentation. This is how a topic looks like. It's basically just a queue. All the operations are, you just write to the back of the queue endlessly or until you run out of space, and your consumers have to read from the queue. This is how a topic looks like. It is composed of many partitions. You can have like hundreds of partitions in one topic, which will be split between your brokers. And basically, this is like a representation of a partition. What is the funny thing here is that each consumer is reading partitions in the topic, and he doesn't care about the other consumers. Meaning that if you have two logstash instances, you can reread the messages and process them differently for 2 different customers, for example, without interfering between each other and without these logstashes knowing anything about each other, which is not so easy to do in RabbitMQ, for example. On the other side, of course, if you want to do parallel processing of the same logs, you can just dump the multiple processors in one consumer group. And this consumer group will, with the help of Zookeeper, of course, keep track of the offset, and your consumers will be reading the messages in an ordered way. Of course, you have no guarantees which message will be read by which consumer, but it will be read in ordered and processed by a logstash or whatever thing in an ordered way. Let's have a quick word about Sequential I/O. So this photo, it is very old. This photo is actually from an Acme article that is very popular with people measuring hard drive things. It is also one of the bases the basis of the creation of Kafka. So here, this is very outdated. This is from 2009. You can see they used Windows 2003 server to measure this. But when we remove sequential memory, random memory, this has probably moved a lot in the future. We don't care about SSDs. This has also, the technology moved a lot in the future now, but we care about disk. So we have the random and the sequential disk reading. There is quite a difference, no? So we see that sequential reading, it's in magnitude faster than random reading from a disk. Well, this is very important. It's because Kafka is a message queue, and each file for this partition for a queue is just a file on the disk, and the things inside are very atomic. It writes, so it appends, and a consumer reads. So it's doing sequential I/O all the time. So this improves quite a lot of performance. Maybe I should go to my next slide. Yes. So this includes quite a lot of performance. So we have only the complexity of O1 when we're reading or writing from a consumer topic. The writes also do not block the reads because they only append to the end of the file. So this is also quite a lot of improvement in performance. Also the storage. So did I just a quick Google search the other day? A random hard drive I found on Google that was 1 terabyte SSD was $330. And we've all seen now the prices of SSDs and RAMs are increasing quite a lot. For what means I don't know why. And the 6 terabyte hard drive found again on Google, it's only €200. So it's like 6 times more the data, and you can also go to Mali Meadow and drink 47 more beers. So this also means that you can process and you can keep on storage in your message queue your logs a lot more time. You can retain them a lot more time, and if you find some other means, you can consume them. This also adds the fact that your consumers can be really, really slow, and you don't care about this. Well, if you use AMPQ, if your consumers are not really fast, the protocol is not really happy. How this is achieved, I'll go back to my previous slide, is that Kafka has no application level caching. So everything is dumped into the kernel page cache. So do people know what is the kernel's page cache? No, okay. I also don't know. I guess there is one person there that knows very well what is it. But basically, modern Linux, or I guess some of the Unix OSes, will try to use all the available memory that's not being used by an application right now to create a cache for you. So why this is superior to having a JVM cache is because first, JVM caches are very expensive when it comes to memory. Second, you have everything stored 2 times. So one time it will be in your JVM cache, then it will go to the file system to get written on. It will go to your Linux page cache. Third, the Linux page cache is a hot cache. Even if your application crashes for whatever reason, this cache will still be there. And if your JVM application crashes and you have application level cache, you have to rebuild it, which takes quite some time. Because Kafka uses heavily caching for things, if you have like a 10 gigabyte cache, it can take quite some time to rebuild it. And yes, so basically everything is dumped in the cache, then everything goes to the file system from the Linux cache. What we also get from this, what also is implemented in Kafka is the very small, it's a lot of abusing of send file. So basically this allows us to save some system calls when we are communicating. So we can push things from the page directly to the network socket. So this saves us, I think, 2 system calls all in all. So this quite a lot improves performance because we were talking about 100,000 messages and all of these calls that are going to be happening all the time on your brokers. And also, if your consumers have a lot of, if your consumers are very fast, and maybe they're faster or as fast as your producers, you're also going to be easily having very little disk activity. And this little disk activity, you can even minimize more by having a very little retention of your log files. So some things will get written to disk, some things will expire while you're consuming in real time, and you're utilizing your disk a lot. A lot of people are concerned when we talk about Kafka that we're using Zookeeper, and some people don't like Zookeeper, some like it. So basically, Zookeeper is the open source version of Chubby, and I am not really expert in neither in Chubby, neither in Zookeeper, but I read a very nice story in this book that I think, if you guys want to do operation, you should read. It's an excellent book. It was about how a lot of people in Google were using Chubby all the time for all of their distributed applications. And when the service received some downtime, they actually they received a lot of downtime themselves. So their application lock was so well made that they're now actually trying to create artificial downtime in Chubby. Now, Chubby is very closely related to Zookeeper. A lot of contribution goes to Zookeeper from people who do Chubby. Also, the other thing that Zookeeper, you don't really need a buffy machines for this. You can use your own IRC bot idling machines for this. I am running the 3 Zookeeper servers on like minimal resources. They're very minimal. Monitoring of them, it's like as long as one dies, you can spawn one up easily. So it's not that evil, considering the benefits you're getting. And before I try to do a little demo, I will give a few words on security. So the biggest concern with Kafka in the past was there was no security before version 0.8.2. Now we're like running version 0.10.1, and we have quite a lot of features enabled. So brokers and to client communicate through SSL and SCSL. So I am not really the security aficionado here. Before I get attacked with questions, I put this straight from the documentation. You can use broker-broker communications with SSL. Also, the client can talk to the broker through SSL, but I don't think they can talk through SSL. And this hits performance quite a lot, but it is still relatively okay. Now, as far as performance tuning goes for Kafka, on the system level, there is not a lot of things to do. Of course, you can read your distribution's performance tuning guide and do it. I will show a demo on a machine that I've done nearly no performance tuning on, except disabling swap, because if you start swapping, then your performance of Kafka really drops a lot. Performance of your page cache will also drop. You should also open a lot of file description for this process, because the more topics you have, the more files you're going to be keeping open. And you can receive some downtime if you don't consider this. There is a big argument about using JBot or a write. So first to say, nobody wants to use any kind of redundant write, because if you use a redundant write, by the time you're rebuilding it, you can easily replicate back all those partitions from another machine. So a lot of people like to use write 0 because of the considered to some performance benefits. Other people like to use JBots. I personally am in favor of JBots because you can mix other different disks to get different performance, but I'm always budget restrained, so yes. The other thing is that you have to consider if you want to decide JBot or RAID 0, if you're using JBot, partitions are not going to spread between different disks. They will come on one disk, stay on one disk, and that's it. People at LinkedIn say that XFS gives better performance. I tend to agree with them. It's not a huge magnitude of difference, but it's still better performance. EXCT4 needs a bit of tuning. For example, you should turn off the journaling. Again, if your broker crashes, even if you lose the file system, you replicate everything back. And journaling really is really slow when you're trying to do fsyncs to the file system. Also, you should do write back, which is the ordered. Kafka doesn't require to have the data option as ordered. On application level tuning, now there is like finding the right partition number. It's the real challenge when you're using Kafka. So more throughput is achieved through more partitions because you're having more parallelism. Also, you can have more consumers consuming things all the time from different partitions without waiting for each other. So let's say you have 10 servers and you have 10 partitions. So each server will only write to one partition. So maybe you're not going to be really saturating the resources on your server. If you have 200 partitions, you'll be writing to 20 partitions. So this is quite much better. You can also have 200 or 20 or even 10 consumers. But again, one consumer can only access a partition at a time. So now they'll be waiting for each other. Also, there is another problem if you have a lot more partitions. This means that you will be spreading the replication between a lot more servers. So basically, you have one machine, which is the leader of the partition, and you have other machines, which are like followers of the partition. So there is two models for replicating this, which I'm not going to talk now. But in both models, the partition which are following get all the data from the master partition. Now, if one partition, the master partition dies, and you have a large number of partitions, you need to re-elect a new master for all these partitions, which can take quite a lot of time. So you have 2,000 partitions. This could take maybe 20 seconds before these partitions become available for writing again. This also causes more latency for the consumers when they're trying to pull from you, because you have to answer them more. There is also the replication factor. Of course, this adds more latency. Here should be producer, not consumer, but I made a typo, I guess. And also memory. I mean, memory requirements jump a lot for Kafka itself and for the amount of heap you have when you do certain replication. There is also acknowledgement factor that you should consider with your producers if you want things acknowledged or not. So performance drops a bit when you do acknowledgement, but it depends really on your use case, if you need it or not. So now, I don't think I have any more. Okay, this I'll talk later. So now let's say I've already created a couple of topics. Now you can see quite well. So I already created this one, just to show. So I'm doing this on a really old machines, you can see. So you see, this is on something called Dell PowerEdge M600. This was released in 2006, which was 11 years ago. It is really slow and really outdated. And it doesn't really have a lot of memory, as you can see. It has like 16 gigs only, while majority of people were running their Kafka clusters on something like 64 or 32 gigs just to get more and more of the caching of the kernel. I've also spawned a couple of test lab machines, so to say. I will be mostly limited by network, I think. So here I will try to produce 100,000. How much is this? 1 million messages. This is so also speed depends a lot on the size of the locks. So this you can also benchmark. Let's do with 100 byte producers. And now this thing explodes and I cannot do my demo. So now it's trying to write like 100 byte messages. And at the end it will tell us how many messages it wrote total per second. And you can also see the latency, which is quite a lot. I don't know. Yes, of course, it exploded. OK, so my demo kind of failed. So I don't know why. But OK, it continued. So maybe I fucked up something. OK, let's try to make less messages, I guess. So, OK, something broke, and it worked yesterday, so I don't know. OK, so let's go. No, I'm not swapping. For sure, I'm not swapping. You see, I cannot be swapping. I don't know, something fucked up, which, I'm so sorry about it. OK, so let's continue forward. It's obviously this thing failed, but such is life. You can easily integrate it. There is like many now free and available integration for multiple services, like collect this, stats the RSys log. Here is a simple RSys log example. You just need a new RSys log. The one that is like in the CentOS and the Rail repo will not work. You need something like 820. I think 815 will work too. You need to install the Kafka module, and then you can just push all your logs there, and things happens magically. Like you can even do decide which partitions to push your logs from different machines if you want to. But I think most of the people are just auto pushing things. And yes, so I'm sorry my demo failed. Majestic. Something worked? No, not really. So something I broke, so I'm so sorry. And yes, does anybody have any questions?
Why did you choose Kafka instead, for example, German?
I don't know, because I didn't even know it existed until now. Why should I choose it and not Kafka?
Less memory, less complexity.
You are not actually. So earlier this day, when I tried things and they worked, I was having a very good performance, but apparently not now. So maybe we can do. Okay, so I destroyed something, apparently, on this small cluster I installed yesterday. Okay, less memory, we're using now just 4 gigabytes of heap on our production machines out of 32, and it's working quite well. Everything else is for the cache, so I don't think it's on memory, it's not a big memory beast, to be honest. We're running 3,000 servers, pushing all the logs. We have a replication factor of 4, so it's quite okay. Any other questions? For complexity, maybe you're right, I don't know. Any other questions? No, okay. Not very impressive with the failed demo, but shit happens.